All right, so sorry about the lighting in the previous section of the video, so I'm just going to go back over how we find the inverse, determinant, adjoint, and inverse of a matrix. All right, so let's say we have a matrix P. Now P is equal to 3, 4, 3 here, and 1. So let's say we want to find the determinant of P. Now, determinant of any matrix, remember the values, these are A, this is B, this is C, and this is D. Now, the determinant of a 2 by 2 matrix is AD minus BC. So all we're going to do is just substitute the values up there. So we're going to have 3 times 3 minus 4 times 1, which is equal to 9 minus 4. So the determinant for P is 5. Sorry about that. So the determinant for P is 5. Now let's find the adjoint. The adjoint are adjoint. So it's A, D, J for short. That is equal to, how we find that? We're going to do what? This is known as the leading diagonal. This one, the 3, 3. The leading diagonal, this is called the minor diagonal or non-leading diagonal. So what we're going to do? We're going to switch the values. But if we switch these values, they're just the same. It's still 3. But assume that we switch them. So it's 3, 3. Now the values on the non-leading diagonal, we're going to change the signs on them. So both values are negative, are positive, sorry. So we're going to change them to negative. So if this one was negative, we'll change it to positive. If this one was positive, this one is positive, so we're going to change it to negative. So we're going to have minus 4, minus 1. So that would be the adjoint. Now to find its inverse for P, so P inverse is equal to 1 over its determinant times the adjoint. So let's solve this. So it's 1 over 5 multiplied by 3 minus 4 minus 1 and 3. Then I'm just going to distribute the 1/5. So I'm going to have 3 over 5 minus 4 over 5 minus 1 over 5 and 3 over 5. So that would be the inverse for P. So I'm going to work another one. So let's say we had K, and K was, let's say K was 5 minus 2 minus 7, and let's say this was 3. And we need to find the first thing we're going to find is the determinant. Then we're going to find the adjoint. So we're going to find the determinant. This denotes determinant. Then we're going to find the adjoint, ADJ for short, and then hence we're going to find the inverse, as in P, not P, but K, the minus 1. So the first thing we're going to find is the adjoint. Sorry, is the determinant. So sorry about that. So the determinant of any matrix is AD minus BC. So this is A, this is B, this is C, this is D. So it's going to be A, which is 5, times D, which is minus 2, minus B, which is minus B, which is 7, minus 7, times C, which is 3. So remember, bracket means to multiply. So I'm going to have minus 2 times 5, that's minus 10. Right here I'm going to have negative times negative, that's going to give me positive, and 3 times 7, that's going to give me 21. Now minus 10 plus 21, that's going to give me 11. So that's the determinant for K. Then the adjoint. Now to determine the adjoint, ADJ for short, remember, I'm going to switch the values in the leading diagonal. So I'm going to switch the values with each other. So I'm going to have minus 2 up here. I'm going to have 5 down here. Then I'm going to change the signs on the non-leading diagonal or minor diagonal. So I'm going to have 7 up here. So it's positive, it's negative, so it's going to turn into positive. This is positive, 3 is going to change to negative. So that would be the adjoint. So remember the inverse of any matrix. So k to the minus 1 is equals to 1 over its determinant times its adjoint. So what we're going to have 1 over 11 multiplied by minus 2, 7, minus 3, and 5. And 5, that's going to be here. So all you need to do is to just distribute, and that will give you the solution for it. Let's hold the paper here. Forget the other tripod. So this is so what we're going to have is minus 2 over 11, 7 over 11, minus 3 over 11, and 5 over 11. So that would be the inverse. So I'm not going to work any more examples dealing with inverse of a matrix or how to find a determinant or adjoint. These are enough examples. So what you could do is to just watch over the video. All right, so let's go on to, let's see what's next in the syllabus. So we started out at the 7th subtopic. We finished that. So the element and the elevate the determinant of a 2 by 2 matrix. We just did that. Define the multiplicative inverse and single. All right, so we're going to talk about hold on, so we're at here. All right, so just find the determinant of a 2 by 2 matrix. We'll also find the adjoint, we also find the inverse. All right. All right, so we need to talk about we talked about the inverse already. Non-singular, singular. All right, so before we talk about singular and non-singular matrix, or I should leave that until we reach simultaneous equation. All right, I'm going to leave that until we reach simultaneous equation. So let's talk about singular matrix and non-singular matrix. So singular matrix. And non-singular matrix. So singular matrix and non-singular matrix. Now a singular matrix sorry about that. A singular matrix sorry, it's all right, sorry about that. A singular matrix, its determinant is 0. For example, let's say we had a matrix K, and matrix K is let's say 3, 2, and 2, 3. So let's say we're going to find the determinant of K. So remember, determinant is AD minus BC. So what we're going to have is 3 times 2 minus 2 times 3. So we're going to have 6 minus 6, which is equal to 0. So because because the determinant is 0, the matrix is considered to be singular. So I'm going to repeat that. Because the determinant for K is 0, that indicates that the matrix is singular. All right, so you need to remember that. So singular matrix, the determinant is equal to 0. So AD minus BC is equal to 0. That's for a singular matrix. You need to remember that. All right, so this is for a singular matrix. So let's talk about the non-singular matrix now. Now a non-singular matrix now, the determinant is it's equal to a it's not equal to 0 then. Let's say is not equal to 0. So it's equal to an integer. So it positive or negative number. So it's an integer except 0. So a non-singular matrix, the determinant is equal to an integer, a positive or a negative number except 0. So the determinant is not equal to 0, but instead it's equal to an integer. So remember, z represents an integer, which is a positive or negative number. So let's see. Let's say we had t. T is 3, 2, 3, and 1. So let's say we're going to find the determinant for t, in that case t. So it's equal to AD minus BC, which is equal to 3 times 1 minus 2 times 3. So we're going to have 3 minus 6. So it's equal to negative 3. So because this determinant has a value, whether it's negative or positive, this is considered to be a non-singular matrix. So you could write something like this. For a non-singular matrix, AD minus BC is equal to Z plus or minus. So plus or minus sign is here. So it's equal to an integer. It's equal to a number other than 0. It's not equal to 0. All right. So let's do probably let's look at 2 questions, because this is not hard. I'm going to go through some past per questions, but just let's go through probably 2 questions and put this up here. So let's see, we have just using that to hold the page for this. So let's say we had a matrix, same K is equal to, let's say, x 3 3 and x, and there's a solve for x given that K is singular. Now, given that K is singular, you need to remember that when K is singular, the determinant is 0. So you need to remember that the determinant for K is 0. So we're going to have AD minus BC equals 0. So A is x, D is x, minus 3 times 3 equal to 0. So remember, this is A, this is B, this is C, this is D. So AD minus BC, so x times x minus 3 times 3. So we're going to have x squared minus 9 equal to 0. So we're solving for x. So, well, this is the difference of 2 square. Can factorize it and then solve it, but let's do it the basic way. So bring over the minus 9, it turns positive. So we're going to have x squared equal to 9. Then we'll find the square root of both sides. So remember, when you're removing square root, you put plus or minus. So x would be equal to plus or minus 3, because the square root of 9 is 3. If they say they want the positive value, give them the positive value. If they say they want the values of x, you give them both the positive value and the negative value. So let's work one with non-singular. So that's just one example. We have other examples that we could go through, but as I said, I'm going to look at some past questions in another video with just the regular matrix questions. So let's look at a question that is when it's non-singular. So let's say we had a matrix Z. Z is equal to 3, 2, A, and 1. And they said that solve for A given that is equal to, let's say, 10. So what they're saying here, they're saying that the determinant is 10. So solve for A given that the determinant is 10. So once I said that determinant is a number, obviously it's a non-singular matrix. So what I'm going to do, I'm going to say AD minus BC is equal to the determinant of Z. So AD, we're going to have 3 times 1 minus 2 times A is equal to 10, because the determinant is 10. So you see that, replace it with 10. So I'm going to have 3 minus 2A is equal to 10. This is a linear equation. So what I'm going to do is to just solve the linear equation. So I'm going to collect like terms. So I'm going to bring the 3 over the equal sign. So I'm going to have minus 2A is equal to 10 minus 3 minus 2A is equal to 7. Divide both sides by minus 2. So A would be equal to minus 7 over 2. So that would be the answer. So that's it for singular, non-singular matrix. So remember, you can take notes while you're watching the video. So what I'm going to move on to now, I'm going to move on to obtain the inverse of a non-singular matrix. So we already find the inverse of a non-singular matrix. So we finished that. All right. We dealt with square matrix already. So what I'm going to do now is I'm going to just finish off matrix by finding the by solving a linear equation using the matrix method. But let's see if I can find a question rather than to make one up. So just give me a few seconds and see if I can find a linear equation. Hold on, suppose I have a password booklet somewhere here. Oh, here it is. So this is supposed to have some linear equation somewhere in it that we can use that we can solve using the matrix method. Once you're doing the CXC exam, it's best to get a lot of CXC past questions to get a feel of how the exam questions are. All right, so these are some questions, some linear simultaneous equations. So all right, so let's see if we can solve a pair of simultaneous equation using the matrix method. So let's look at this one. So we have 2x plus y equals 7. We have x minus 2y equals to 1. Now solving solving a pair of simultaneous equation using the matrix method, you first have to put the simultaneous equation in a matrix form. So it's very simple. Usually they say that it's you should put it in the form ax equal to b, or px equal to q. Sometimes I give the forms like that. So we have to put it in the matrix form before you can actually solve it using the matrix method. So what you need to do, as you see the values, you just write them back down. So the A represents a 2 by 2 matrix. The X represents a 2 by 1 matrix, and the B represents a 2 by 1 matrix also. So B represents the results, as in what they are equal to, sorry. So it's 7 and 1. X represents the variables, which is x and y. X goes to the top, y is go to the bottom. And then the 2 by 2 matrix just represent the values, as in the coefficients on each variable. So change the color. So right here we have a 1, right here we have a 1. So I'm going to have 2, 1, 1, minus 2. Hopefully you understand that. So I'm going to go over it with another question. So let's say we had another matrix on this side, another simultaneous equation on this side, sorry. So let's say we had 3x plus 2y equals 13, and we have x minus 2y equals to minus 1. So remember, we're going to put it in the form px equals to q. So remember, the P represents a 2 by 2 matrix, X represents a 2 by 1 matrix, and Q represents a 2 by 1 matrix also. That's the order of the matrix. So remember, Q is what the equations are equal to, 13 and minus 1. X represents the variables, which is x and y. So x at the top here, y at the bottom. X always come before y, and then the values in the 2 by 2 matrix represents the coefficients on the x and the y. So we're going to have 3, 2, 1, and minus 2. So that is how you represent a pair of simultaneous equation in matrix form. Now to solve it, we need to find the inverse of the 2 by 2 matrix. So A inverse is equal to 1 over its determinant multiplied by its adjoint. So remember, the inverse of A, sorry, the determinant of A is equal to AD minus BC, which is, remember, leave it up and show you. This is A, this is B, this is C, this is D. So it's going to be 2 times minus 2 minus 1 times 1, which is equal to minus 4 minus 1, which is equal to minus 5. That's the determinant for A. Then we need its adjoint. For more, we need to find the inverse. So we need the adjoint. So the ADJ, remember to find the ADJ, what we do? We switch the values in the leading diagonal. So I'm going to have minus 2 at the top here, 2 down the bottom. And I'm going to have to change the signs on the non-leading diagonal. So this is going to be minus 1, this is going to be minus 1. Now, the inverse for A inverse is equal to 1 over 5. Remember the minus sign, minus 1 over 5, times the adjoint, which is minus 2, minus 1, and 2. Now, after finding the inverse, usually, because what they taught me in school was that I should multiply, use the inverse to multiply both sides of the equation, or the matrix form that we have up here, multiply both sides. But if you're solving the simultaneous equation using the matrix method, you don't have to multiply the left hand side by the inverse, only multiply the right hand side. Now, if you should multiply both sides, let's see, I'm going to solve it, show you. So rest this here so that you could see what I'm writing down. So I'm solving. So what I'm going to do, I'm going to multiply the first thing I'm going to do is to multiply both sides to see with the inverse. So multiplying both sides, I'm going to have A inverse times A x equal to A inverse times B. So I'm multiplying both sides by the inverse. So make sure that you have the inverse. When you're multiplying the right hand side, make sure you put the inverse in front the B, in front of the 2 by 1 matrix, because remember, you need the number of columns for the first matrix to be equal to the number of rows for the second matrix. I'm going to show you that in a while. So I'm going to solve this side first. So I'm going to have minus 1 over 5 minus 2 minus 1 minus 1 and 2 multiplied by A, which is 2 1 1 minus 2. Now I hope this isn't getting boring, but just pay attention for me. So when you multiply the left hand side, the inverse of a matrix by the original matrix is going to give us the identity matrix, and this is what you should know this. So the inverse of a matrix times the original matrix should give you the identity matrix, and the identity matrix is 1 0 0 1. So let's see. So forget about the coefficient, the scalar multiple for now. So I'm going to just multiply 2 by 2 matrix, and I'm going to do it the short way. So minus 2 times 2, that's going to give me minus 4. So remember, first row, first column. Then minus 1 times 1, that's going to give me minus 1. So that's first row, first column. So we're going to move on to first row, second column. So minus 2 times 1 is going to give me minus 2 plus minus 1 times minus 2, that's going to give me plus 2. So remember, there should be a plus here, but because the minus, it's going to change back to minus. So we finish with the first row, first column, first row, second column. So we're going to move on to the second row, first column. So it's minus 1 times 2, which is minus 2 plus 2 times 1, which is 2. That was the second row, first column. So we're going to move on to the second row, second column. So it's minus 1 times 1, that's minus 1. And 2 times minus 2 is minus 2. Put back the scalar multiple. Rewrite back the scalar multiple. So we're going to have here minus 4 minus 1, that's minus 5. Minus 2 plus 2, that's 0. Minus 2 plus 2, that's 0. Hold on, seems like we made a mistake here. So 2 times minus, this should be minus 4. So this is going to give me minus 5. So I'm going to distribute this negative 1/5 inside the brackets. I'm going to have minus 5 over minus 5, minus 5 over minus 5. I'm going to have 0 minus 0 over 5. I'm going to have 0 over 5. I'm going to have minus 5 over minus 5. So as you can see, x is going to be here, xy, 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 xy. So as you can see, when you cancel down here, you're going to have 1 0 0 1. So when you multiply the left hand side, it's always going to give you the identity matrix with the values that you're supposed to solve for. So you don't have to do this side unless they say you're supposed to do it. But this side is always going to be equal to the identity matrix. Now solving the right hand side will give us the result. Now so I'm going to put equal here. The inverse is minus 1/5 minus 2 minus 1 minus 1 and 2 with the values that it was equal to 7 and 1. Now if you had put the 7 and the 1 in front, you'd actually, so remember, this is a 2 by 2 matrix and this is a 2 by 1 matrix. You need the number of rows in the first matrix to be equal to the number of you need the number of columns in the first matrix to be equal to the number of rows in the first matrix. So you can multiply them. So once they correspond like this, yeah, you can multiply them. They are conformable. So let's put back the coefficient here. So remember, when you multiply a 2 by 2 with a 2 by 1, the result is going to be a 2 by 1. So open a bracket, first row, first column. So I'm going to have minus 2 times 7, that's minus 14. Plus minus 1 times 1, that's minus 1. So we'll finish with first row, first column. So I'm going to move on to second row, first column. So minus 1 times 7, that's minus 7. And 2 times 1, that's 5. That's 2, sorry, that's 2. So close bracket equal. So I'm going to have minus 1/5. I'm going to simplify what is inside. So it's minus 15 and minus 5. I'm going to simplify these. So this is 2. So what we're going to have is minus 15 divided by minus 5. And we're going to have minus 5 over minus 5. So what we're going to get for our result is actually 3, because 15 divided by 5 is 3 and 5 divided by 5 is 1. So those would represent the solution for our first question, which is that. So I'm going to solve the second one, but I'm going to solve it quicker than how I solved the first question. So what you can do is you can just go over the question, the video for me, and you will understand it properly. So remember, so I'm going to rewrite it. So you have 3x plus 2y equal 13. We have x minus 2y equal to minus 1. So I'm going to put it in the form of px equal to q. So 2 by 2, 2 by 1 equals to 2 by 1. So this is 13, negative 1. This is x and y. This represents the coefficients. So it's 3, 2, 1, and minus 2. So remember, first thing we need to do is to find the inverse. So the inverse of p inverse is equal to 1 over its determinant. The determinant is AD minus BC. So right here, we're going to have 3 times minus 2, that's minus 6. So it's AD, so hold on, 1 over AD minus BC times the adjoint. So what I'm going to have is 1 over 3 times minus 2. I could solve it like this as well. Minus 2 times 1, which is equal to 1 over, this is 3 times, that is minus 6, and minus 2, which is going to give me minus 1 over 8. Remember the negative sign, if it's at the top or the bottom, it doesn't matter. So the adjoint, to get that, I'm going to switch the values in the leading diagonal. So it's minus 2, 3, and change the values in the non-leading diagonal. Change the signs on the values in the non-leading diagonal. So it's minus 2, minus 1. So we just carry it down as we're going along. Carry it down as we're going along. So that would represent our inverse. So as I said, you don't have to multiply the left hand side because it's going to give you the identity matrix. Just multiply the right hand side. So we're going to have xy equal to minus 1 over 8 minus 2 minus 2 minus 1 and 3. Remember, put the 2 by 2 matrix before what it's equal to, which is 13 and minus 1. So let's see what's going on here. So minus 1 over 8 bracket, we're going to multiply first row, first column. So minus 2 times